some kind of schema, and then where you have fact table and some dimensions around it. So basically, you have two options. You can do the following. You can overwrite, for instance, an old value with the new value, then you don't need to change anything. And then or you can save somehow the new value of the dimension table and keep the old value as well. On the next slides, we're going to review it. What exactly means why you need to rewrite the old value. Just imagine that you have a classical sales and you have a product, and the product got a new name or some additional name, or I don't know what. And this is like, as long as the product names are saved inside the dimension tables, you need to change dimension table when such change happens. And this is exactly what is described next. You have basically four approaches for slowly changing dimensions. So like you have two main approaches, and then you have sort of the philosophical ideas how to implement them. Then you have sort of types 0, 1, 2, 3, and 0 is retain original, passive, no updates required. So basically means you are doing nothing. When the new dimension comes or new update comes, you just ignoring those changes, just blank like this. So easy to implement, easy to run, nothing happens, but as long as something will be changed, you will never recognize it. Then you have type 1, override. This disadvantage, you lost all the history. So previously you know that the product was named black, now it's named white, and you will never know if you override the name that it used to have another name. Then there are other two solutions how to overcome this problem with maintenance of the history. You can add a new row or you can add a new attribute. How it's done. So I think our right example is quite simple. So you find a row, you replace the value or update the value with the SQL query or whatever mechanism you got inside your ETL tool, and then you're done. And then add how the add new row could possibly function. So you could possibly sort of extend each of your dimension tables with the three additional columns: begin date, end date, and is current. And you'll track the progress using those mechanisms. Let's look how it's exactly done. Add new row. Look at this table. We have the product key of the product 2. Its department was education, and you had some begin date and some end date, and then is current here is false. Then you have a sort of new product update of the product 2. Now it's handmade, it's got a new ID, and you see what you are doing here with the old product 2. You sort of deactivate it by inserting end date and is current. Why you should use, maybe it's a good idea to use 3 of them. Actually, is current could be like more or less, could be enough sometimes. But you also, by using begin and date, you can also see the history, when it was changed exactly. And it's also sometimes easier to filter based on those dates. I hope more or less the idea is clear. So you're simply changing the sort of, you're changing the structure of the table, of the dimension table, and those 3 columns are not connected to a particular column of the dimension of particular entry of a dimension. It's connected to a whole entry, not a particular field of it. So it means if product key changed, actually it should not, if the description changed, if the department will be changed, you'll insert a new row and mark it as the is current, and then deactivate sort of the old one. There are also categories of ETL tools available out there, and basically there are 4 of them. You have self-implemented one, so like a bunch of scripts that are pulling the data, putting them somewhere, and then everything works. Then we have a standardized ETL tool with basic configurations, like you'll download Pentaho, PDI, Pentaho Data Integration, or Talent, or Apache Nightfire, or whatever, or Luigi or Airflow, and you just use the standard things that are there. Then you also could like use it in a complicated way. Usually the tools allow you to run the scripts inside them. So you will just manipulate some fields in order to instruct some values and so on and so forth. Then you can implement your ETL using a more sophisticated higher level programming language like Python, C#, and so on and so forth. I used it. And one of the widespread ways of dealing with non-standard data inputs is to implement your own ETL tool using a custom scripts or using a language of your choice and libraries that are offered. So for instance, it's okay for Airflow, you are forced to use Python to create the data pipelines. Or in the case of C#, you have something called SSIS, and you can use those developed and offered by Microsoft services to boost the performance or to sort of to let the Microsoft or let the tools from the Microsoft do the job that we need from the ETL. There are also a key criteria to select the ETL tool, which are important. First of all, you have to ask what kind of infrastructure you have. What is also important, really, what connectivity and connections are available inside the tool. So for instance, if you check Apache Nightfire, it will have all 120 different connectors. So it's not only connectors to HTTP or connectors to a FTP server. It's also connectors to the Kafka, to a database. You can always connect to a particular database, relational database management system, using ODBC API, but sometimes they're really slow. And when we are speaking about the huge amounts of data, you would like to improve the speed of your ETL. That's why it's important to use those connectors, because they're usually fast. Then you have to take care of check whether the battery is included, like connections. I already told you transformations are available, filter of the data wrangling. Then also important, cron-like job scheduling within the tool. Why? Because sometimes it's easier to cron the jobs inside or to schedule the jobs inside the tool rather than rely on the Windows scheduler or the cron job on the Linux. Then also availability of data, pipelines, testing, and all that stuff. Then usability and platform support. Tools, for instance, some tools are not runnable on Linux, or some tools are not runnable on Linux. For instance, if I speak about the Pentaho BI, which is not, Power BI, which is not directly an ETL tool, but had a good integration with external sources, it could be that it runs only on Linux. Then performance, scalability, debugging facilities, data quality and profiling, usability. Reusability means you can dump your pipelines or your ETL jobs into sort of Git or something, and it's not like a pure GUI based solution where you always need a tool to run it and to test it. Then the support of the batch and real-time processing, and some future perspectives like community supports, updates, documentation, and so on and so forth. They are really trivial, those criteria, but if you know them, then it's much easier to screen the tool and say, okay, this is a good fit for us, this is not a good fit for us. Here, I also spoke about the batch ETL or stream-based ETL. And this is sort of, you can read the publication here if you want. There is also a distributed ETL processes. Why one would like to distribute the ETL process to run as many jobs as possible on the one side. On the other side, it's to like not to block the other jobs, for instance, from running, and to be able to ingest the data into to the multiple sources. Because when we're speaking about the sort of enterprise service bus based ETL, then you have not a single client in terms of data warehouse. You have also other clients as well. So it could be the second data warehouse. It could be some other system, some data-driven machine learning, deep learning systems, and so on and so forth. Then you have what also keep in mind. So I think it's obvious, but you need to keep it in mind for the future. It's much easier to implement a batch-driven or batch ETL rather than the implementing near real-time or real-time ETL ELT process. Why? Because batch process sort of, you know when it will be fired, when it will be started, when it will be stopped. In real time, the changes are really fast, are happening really fast, and to test it, you really maybe need a real API that is like ingesting data to the data warehouse through your ETL. But still, you have also other problems. Let's go through this through the list. If you have a multiple data sources to integrate and you need to sort of send those integrated data to the multiple targets, then stream processing is a tool to be used. If your problem is to back up the data and you have a sort of problems with performance degradation, then sort of log-based change data capturing. So when you like ingest like a small logs could be a good way to go. And when you have like the problems with the data source, or when you have your data source is overloaded, still you can like overtake. That's data source overload means you have a system where you pick up the data, and this is sometimes overloaded because you are asking too much too often, or it's like really weak, and that's why you maybe overtake those parts. You can say, okay, I'll just request you once in a day, and I will keep the data, or I can request you multiple times in a day and just select only small parts of the data. You think it's like an abstract, but it's not the case. Why? Because usually it's easier to dump all the data from the target and then work with that inside the ETL too. And it's a norm load on the source, on the system that you are using as the source for your data. I also mentioned here a couple of tools. There is really many tools are listed here. There are ETL tools by definition. So like I mentioned, OLITube, Pentaho, SSIS from Microsoft, and Talent, OpenStudio, Informatica, Oracle, Apache NiFi. And there is also some tools that can be used as part of the ETL, which is done. For instance, RapidMiner, OpenRefine. We'll see the OpenRefine, Apache Kafka, Heka, Logstash, and many others. What is also, I want to explicitly mention, data pipelines. There are also some tools that are on the market and got the name data pipelines. And it's like, you can treat it as a rebranding of the ETL or ELT processes. Not always, but usually you can also benefit from those tools For instance, there are a tool called Grid Expectations. So it's a Python package that lets you to validate. If you have a pipeline, for instance, in Apache Airflow, you can use all those grid expectations to validate data before importing the data, which is really great. So you have like complete pipeline in the same language, which is open source, and you can always like update it. And this is an example of the pipeline. It sounds a bit complicated, and it's actually complicated to organize the import of the data from the multiple machines, from the archives of the XML data, and put them into the data warehouse Hive. So we need to implement different tools with the project group. For instance, agent for an XML transformation, then parser for the XML file, and then importer into the dataset, into the database. But we did it with the idea we have really huge amount of data, and we need to use Hadoop to crunch all those data and be able to process those. Well, as we expected back then, terabytes of the data. That's why it was like designed to be scalable. Nowadays, it could be like maybe not, could be over complicated because we have better hardware, better tools, and better support for the open source. But still, you can't overcome some problems. Like the problem with XML, you need the whole file. If some parts of the file got lost, then you have invalid file, and you can't work with invalid files in this case. It's different in comparison to log files. If you sort of lost part of the log files, so it's fine, because it's fine in terms of the log file or logs that you are gathering won't be corrupted. You can still work with them. Do we have questions about the ETL tool? I hope it's. Just a second. Just inform Andres that I will need a bit more time than planned. Okay, I didn't expect that initial presentations of today will take too much time, but it's fine. Do we have questions about the ETL? So during the exercises, we'll, this is a second.
Sorry, wir stimmen uns gerade ab.
Ja.
Victor, wie lange glaubst du, brauchst du noch?
Ich glaube noch 25 Minuten, 20 Minuten.
Ja, dann, okay. Dann wünsche ich euch einen schönen Tag. Dann werde ich aber nicht mehr mit Kapitel 6 anfangen.
Okay.
Ich habe es schon hochgeladen. Ansonsten wünsche ich euch einen schönen Dienstag, beziehungsweise vielleicht sieht man sich ja sonst immer am Freitag. Und das bringt einfach nichts, weil dann hast du so viele Themen drin. Den Switch, das bringt es nicht. Für eine Viertelstunde brauche ich da nicht anfangen.
Genau, dann sorry nochmal, Andreas.
No
Ich würde es einfach, genau.
Viel Spaß euch.
Ja. Now we have all the time. So if we have more time, then I will ask a couple of questions about the ETL as long as we are done with the part. So first of all, the question is, what means slowly changing dimensions? It's a tricky question. Unfortunately, there is no a single answer to give. Maybe let me restart it. Just a second. I can assure you that the D is not the right answer. I restart the poll. Yeah, finally. So A, dimension that deletes its value after a particular date. So it's not correct. So there is no deletion of the date after a particular date. Then let's look at D, dimension that updates its value after a particular date, which is almost the same as the A. So it's like delete and update after a particular date. No, not a good fit. Then you have something on C, dimension that use cron jobs to monitor the fact table. It's actually cron jobs in this case means scheduled jobs on time, which is similar to A and D, which is wrong. And the right answer in this case is B, dimension that lets track changes. So dimension, so it's a way of dealing with the dimensions in the way when you can track the changes that you are making, or ETL tool is making on the so now some of you guessed it correctly. I hope it's clear why. So let's go through the types. You can open the slides to answer the question, which is quite easy. What type? 0. So it's very so I'll publish the results. So it's the correct answer is C, retain the original. So type 0, it means we're doing nothing. So we designed the schema, we put the dimensions, and we forgot about them, that they could be updated or something. We'll just let the system run, which is sometimes totally fine. Depends on the dimensions. What is tape 1? So it's not C for sure. You don't need to learn those type 0, 1, 2, 3 by heart. It's important that you understand what could be possible go wrong or how you can possibly handle it. I'll publish the results. Yeah. So it's A, it's right. So you don't track changes in 1, you just like updating existing dimensions. So it means you retain the old keys for your references from the fact table point of view. So which is nice, but still you are losing a history of those updates, which could be really crucial. And what is the difference between 1 and 2? There is no difference, which is not correct. Yeah, type 1 is better because less space in the table is used. Yeah, it's better, but it's not due to the table space. If you're speaking that, if you are arguing that type 1 is better, then the argument should be not the space. The argument should be the simplicity of the implementation. Type 2 lets us track change in dimension easier. Type 2 is better because more space in the table is used. So the answer is C. So because D is sort of blah blah. So it's, come on, we're not speaking about the space here. So type 2 is better because you have a way to track those changes. And for your information, we use just like those basically 4 types. Yeah, basically the dealer you can ignore. You have basically 2 times to track the changes without change tracks without tracking the changes. And how you track the change, it's totally up to you. You can be creative, and it's really up to the SQL queries and up to the queries and the engines that they're using. So, and you saw a basic example how one could do it. So you have dates, you have like is current to simplify the select, and you can still have the history. So now, thank you. I'll just publish the results. So you guessed it right. It's C. I think it's have to be easier. I'll move to the slides. So I'm going to speak about the visualization now. Well, you already started visualization last week during your exercise, but still I want to argue that it makes sense. What is visualization? Visualization is a form of presenting the data in a way that the information that inside the data will be sort of will be put it into the front. So it will be like so you're not discussing the data, you are discussing the information in this case. So you have like, I like this diagram because you know know the Lego, you have data like random Lego, then you have sort of arranged it in some way, maybe on colors, maybe on something. Then you could sort it based on some criteria, amount of, basically what kind of criteria you can have, 2 criteria, weight and the amount, color making. So sorting using the color, you can also potentially do it because you have this classical light distribution from the physics. You can also try to sort them according to this. But usually what you target is to present the data in some way that will be meaningful. For instance, in this case, you use the bar chart like representation with using a Lego, which is really cool. I already motivated it. Sometimes it's a better way of communicating, and sometimes it's harder to. It's easy to lose the data, but it's harder to lose the visualization in key. Just imagine that you put it on the slides, present it to your stakeholders, put it somewhere, and the next one comes can reuse your PowerPoint or whatever you created, and you have a visualization inside it, and you cannot simply dump all the data that you have for your like potential presentation. And information that you have on the visualization, it's really more valuable in comparison to data for the end decision. You have different types of data, so like nominal attributes, ordinal attributes, metrics, and ordinal attributes and metrics. So like you have, for instance, in cases of nominal attributes, they're important. Now I just mentioned you the example of sorting, and you need to have a criteria to sort. So it means you can't sort all possible data. It's impossible. But you can change the data in the way that it will be sortable. So just to be creative. So by creating some metrics like revenue, number of customers, or whatever, number of entries. And this is like how you transfer those nominal and ordinal data in something that is aggregatable and sortable. You have a different categories of data comparison, which means data visualization, because when you're visualizing, I already mentioned to you, you're sort of explicitly comparing the data. So like in case of, as an example of the Lego bar chart. Then you have sort of data comparison based on the components, where you can compare the percentage out of total. So for instance, size, share, percentage of total, I already mentioned. Then you can compare the items. So you can compare sort of ranking between them, smaller, higher, better, or whatever. So you need to have this comparison feature. Basically, if you're familiar with programming language like Java or any kind of other object-oriented programming, you know what means the idea of comparison. If you implement your customer item there, you need to define a method that will help the programming language to decide which object out of which instance of the object, bigger or smaller or equal to another one that you're comparing it with. Then you have a time series, which is like the time perspective. So there you have sort of change, growth, then decrease, and so on and so forth. Then what is also important, the last two ones, you have a frequency distribution, which is to some extent, if you actually use the frequency distribution and apply the data, sometimes you can see the normal distribution or Gaussian distribution in the data, which helps you to, for instance, to find the real mean or real average of the data with the sigma and all that stuff. And then for sure, the last what you have here is correlation. But you have to be aware that correlation does not mean it's causality. It's not implicitly suggests, it's not implicitly exists when the correlation happens. So the two independent processes could also correlate with each other, but it's first of all means nothing. So there are also some charts. The one called use. The most used ones, I think, are a bar chart here, or a column chart, they're also called. So why? They're basically, you have the same information on the column charts as here on the pie chart, but pie chart is to some extent tells you only the parts within a whole. That's why that's only what you have. But when you have a column-based chart or bar chart, you can compare between the values or between those aggregated stuffs. Then you have another column chart and bar chart are the same in this case. Then you have some curves that you can also post, that you can also like use. It's like important to use them for time scales. And you also have some, if you don't have any kind of pattern on the data, you can just simply drop all the tables, just drop them on the plot and see what's coming out of it. This is like dot or scatter chart. Then I have more sophisticated ones like Sankey diagram, Venn diagram, heat map, tree map, stacked bars, and so on and so forth. I did not explicitly mention listed them or viewed them here. Why? What you have to always keep in mind, if you are using something that is not intuitively clear, for instance, heat maps or Sankey diagram, before you will present it to someone. So like assume you don't know your opponent and you don't know your auditor. You firstly have to explain clearly how the diagram works, how one should interpret the diagram. This is really crucial. Otherwise, you have a problem of miscommunication. So you'll present something, you'll assume this usually happens to box plots, for instance. People don't know those risky and how it's really built, and you need to, for instance, explain how the box plot is organized. And this is really crucial for Venn diagram. For instance, Rene just used them, and as long as we are all sort of in academia for a moment, we know what they mean. But if you're using something abnormal, for instance, heat map, and you use a bit different colors, for instance, heat means, in your case, green or not red, I don't know why, you have to explain it explicitly. And those scale is also important for heat map and so on and so forth. I hope you grasp the idea of the chart types. Then there is also a nice diagram, like how to decide for which chart is to go. There is a link also, you can like click the link and read more about it. I just put it here for you later to see. If you are struggling, sometimes I'm really struggling to select the right chart for a particular task. This is maybe a no-brainer, so you can go through this treat in order to decide which kind of chart you are going to use, you would like to use. Let's go through the rules for designing the charts. I hope you can still hear me. Actually, I already mentioned some of them. Think about the metrics or KPIs, key performance indicators that best suits your needs. Avoid combining unrelated charts into one. For instance, for dashboard, because then if they are not naturally connected, those metrics, it's really hard for the people to interpret them. They will be simply like maybe angry because they can't understand it. Consider the importance of direction when presenting the data. It's a classical way from left to the right, not from right to the left. It depends on the country, but let's speak from left to the right and from bottom to the top. So if you put something on the top, the people will automatically assume that it's really important. If you will put something into the bottom and hide, they will automatically assume that it's not important. Avoid cramming too much information into each chart. It's basically better to, it has to be sort of like a tree where you have leaves with detailed information, and in the root you have only the key performance indicators or some important metrics to be used. And you always have to have an possibility to let the users dig deeper and find their values. Then make sure that any data label or data legend are legible, which means, so in case you're speaking about the, you can't simply use 1, 2, 3 for the days of the week. It's better to use Monday, Tuesday, Wednesday, Thursday, and so on and so forth. And you have to mention that this day of the week, and the title of the diagram should be aggregated view of the data aggregated by day of the week data, blah. So this is like you usually forgets about those small things, because when you design the diagram, you have in your mind, okay, what you're doing, but you usually one forgets usually that is the way to communicate to others, and they may not know what is the meaning of a particular access, for instance. Then readability, I already mentioned to you. I don't know whether we have had 2 guest lectures in January that are going to be about the content. They are going to speak about some maybe visualization. Well, last year we had a lecture on visualization from Bjorn. Maybe this time he will also speak about the visualization, and he had there really nice examples how not to do visualization. Then description, I already spoke. Be consistent in choosing chart types. So this is also important. The tools may offer you 1,000 types of different charts, but be consistent. Be consistent means try to avoid using different charts if it's not really needed, and do not use the same chart or different charts for the same data. This could be really annoying. So I need to like think about the chart, think about the data, then understand, okay, those charts are the same, have the same data, screw you, why you did it to me, and just lost all the time. Try to use most of the times, most common chart types. I already mentioned why. It's common sense, because otherwise you will need to explain how the chart works. Don't play too much with the colors. Yeah, this is like obvious, but still, I'm really bad in those color things. But there are well-known palettes that you can use. For instance, Tableau 20, I think, if you like search for the term now. So they give you colors that you may use for your visualization, and stick to maybe to the standard colors. I mean, I do not mean red, green, blue, and so on. I mean the sort of like, for instance, Bootstrap CSS framework got the standard colors that they're using, and Tableau got also standard colors, Excel also, and so on and so forth. Try to stick to them. Think about the order. So I already mentioned to you, avoid using too much effects on different, so it's also true, like if something like is popping and showing and changing the color, it's not a good thing. And ensure that the design charts are placed into relevant sections, so it's more or less about the dashboard. So when you have to group your design works together, so you have to like be sure that they fit each other. I don't think that I listed some visualizations tool here. I just want you to know them, that's why. There are also pros and cons for each tool, but I'm going to speak about the two of them. I'm going to speak about the Power BI and Metabase. I'm not going to speak about the rest of them, but some of them are really nice and open source. For instance, Apache Superset, it's an amazing tool, but sometimes it's hard to deploy it. Metabase is a bit easier to deploy, and Power BI, it's amazing when you are familiar with the Windows. It's amazing tool, just like you install it and you just use it. So this is exactly the slide on the Power BI. The advantage of the Power BI, it's got an integration with the tools, with the whole stack of Microsoft, as they usually doing. They have also their shared apps or some add-ons and so on and so forth. I'm only speaking about the Power BI. Last time someone told me what as the best tools to be used, and Power BI could be one of them. If you really need to really create something fast and reusable for yourself, Power BI could be, and you have a Windows machine, Power BI could be really a nice tool to start. For instance, if you're familiar with GitHub, this is like what one could do in half an hour to get a dashboard with some important KPIs for you using your GitHub account. Power BI got a native integration with Power BI. I mean native. They have a predefined connectors where you can like fetch the data from GitHub and play with them to create dashboards like this one. And then ClickView, we already used one of the Click ones. So if you are more into BI, if your company stick to Click products, you can also download and install ClickView desktop and play with it. And ClickView will use, or I'll stick, it's more or less the same tool as the Metabase. So Metabase, I'll just explain you in detail because we're using it in doing our exercises. The huge advantage of Metabase, actually a couple of advantages. First of all, it's web-based completely. It means if you create something, export something into HTML, you can always send it to someone. Second advantage, It can be easily deployed using, for instance, Docker container, and it just simply runs, and it's sort of enterprise ready. And the third advantage, it got an auto discovery function. And and the third advantage of the Metabase, it's that you have sort of combined way. You have like only the tools that you need for the visualization. In comparison to Apache Superset, it's more sophisticated. It has more features, but sometimes you don't need all those features for simple dashboards and so on and so forth. Yeah. Do you have any questions? So far we spoke, not today only, but the last week, about the open source solutions. We spoke about the ETL tool. I hope you could grasp the idea. You definitely implement at least once an ETL tool in your life. And it's like a complex process, complex in sense of it's not hard maybe, but it's complex and requires a lot of time and work to be done in order to implement a really clear and robust ETL process. And then we spoke about the visualization tools. It's hard to speak about the visualization tools without showing them, but I hope that you'll proceed with the exercises so you have a chance to use those visualization tools for the tasks I gave you. Yeah. So it's better to use it once and understand the logic than hear 1,000 times from me and say, okay, it's too cool, but what should I do with it? Do you have questions? Are you still able to hear me? That's perfect. Do you have a question about the exercises or something? Something is not working or whatever? Okay, as long as you don't have questions, then see you on Friday. Hear you on Friday, and we'll have a new exercise on visualization this time. So it's like the continuous of the old exercise on visualization with Metabase. Yeah, and have a nice day, and see you on Friday. Thank you for your time.